Hello. Can you hear me?
Yes, sir. I think Swamiji will just introduce you. Please wait for a moment, sir.
Oh, no problem.
Yeah. He has joined. Now he'll do the introduction, sir.
For me, please stream
Just a minute.
Mr. Jitu's about slide. Yes. Good afternoon, Mr. Jitu.
Hi,
Yes, we have made one small slide so that about you, so that just now it will be streamed, and then we will begin.
Thank you.
This is a very strange situation that, of course, the number of participants are little less. Today is Vishwakarma Puja in our state. That is why everyone is in the festive mood. And this is actually the kite festival, you see. Do you know this in Bengal? This particular Puja day, that is the kite festival. So that is why mostly the youngsters are busy with this flying the kites. But still we have one participant from Ladakh. So this is Tashi. Tashi, you please switch on your video. Tashi.
Yes, sir.
Please switch on your video. And please have interaction with us. This is a very unique opportunity that you got, our Mr. Jitu. For me, you got his slide, I hope. Hello?
Sir, I'm just.
Yes. Just a minute.
Recording in progress.
More students are joining. It is a good opportunity to interact with Mr. Jitu. And let me ring up Sandeep. I told him that you should join. Where is Sandeep's number? Today, join कर ली ना? Oh, अच्छा. তো জিতুর 1 ঘন্টা চলবে। জিতু's lecture is for 1 hour, and then Professor Rajiv Mukherjee, that or from Texas, USA, he will join. Okay, please. Okay. If you are free, you join it. So, our honorable speakers and Mr. Jitu Niruthambat. This is you see your spelling is such that we are not much capable of pronouncing this. I don't know whether the material what you develop, what you deliver, that will be also like this or not. Actually, I don't know much about the software discipline. We are basically core people. Of course, you are also core people. You are basically an electrical engineer or what? Or software.
I am an electrical engineer, then postgraduate of digital electronics.
Oh, I see. Very good.
I was
Mr. Jitu, so he is a co-founder and CEO of Atoll Solutions Private Limited. So Atoll means actually whatever solutions is required. So he is having the solution. So whatever problems are there. So such is Mr. Jitu. So he helps businesses measure, innovate, and win with IoT. And this company is in Bangalore, Arman, Karnataka, India. His mail is being given. So his areas of interest, over 25 years of experiences in embedded technology. Out of that, 16 years in marketing and business development, running business to business IoT company over 5 years with a sharp focus on research and development. Successfully built wireless ecosystem for TI in India and the Asia Pacific region. Lead a WW partner management team, USA, Europe, Asia Pacific from India. Worked in Texas Instruments. So, man, he is a man from Texas. So much experience he has had in Texas Instruments. USA as a product marketing manager for OMAP before coming back as director of business development for wireless business in India. Over the years, built strong relationship with wireless ecosystem, operators, application developers, OEM, ODMs, etc. Now living his passion of being an entrepreneur in the area of wireless Internet of Things domain. His specialties are building and enhancing ecosystem worldwide, understanding and managing technology, embedded product definition, development and sales, business development in India, in Asia Pacific region, very good working relationship with wireless, consumer electronics, and OEM and operators, innovative business models, win-win contract closure. So this is about Mr. Jitu Niruthambat. And you see, I got his contact from my student, Mr. Sandeep Nanda, who is also entrepreneur of a software industry, had a long innings in USA and settled now in Bangalore. So basically, Mr. Jitu is he's electrical engineer and then made himself as a specialist in so IoT and other software measures. So over to you, over to Mr. Jitu for his excellent presentation. Please.
Oh, thank you very much. What I'll do is I'll share a slide.
Yes, surely.
Yeah. Basically, I am a guy. I think how many people are there in the? How many people are there in our now?
15.
That is very good. I think what you can look at is that you can stop and ask me questions anytime. I am a guy who likes to understand by explaining. That is why I just wanted to make sure that We don't. We cannot. We can make it informal. Okay.
Yes.
1 second. I am just seeing how to present. 1 second. This one is stuck here. Can you see my screen?
Yes.
Yeah, sir.
Yeah. What I'm doing is that this is maybe around 25 minutes I'll take to go through my slides, and then we can discuss from you guys are all chemical engineering guys, right? Most of you are chemical engineers.
Yes.
We can, you can ask question and understand. The idea is that from a very high level, I will take you through what is Industry 4.0. You will hear Industry 4.0 everywhere. What is Industry 4.0? And then I take two parts of, two important parts which I have been working on to enable Industry 4.0. One is location intelligence, other one is sensor intelligence. We'll go through some of that and understand them a little bit detail. And then I have few notes about how Industry 4.0 is doing, whether in India or anywhere in the world. And then we can have a QA. Okay. Consider it as very informal. You can stop anytime and ask question. Before I start, I just wanted to spend few minutes on what does my company do. Okay. Atoll is my company. As Swamiji pointed out, we are a sensor to cloud IoT company. Our vision is to make sure that location intelligence reaches everywhere in the world in terms of any business. Whatever value location intelligence brings in, I will tell you what is location intelligence. We wanted to make sure that it reaches everywhere, whether it cannot reach places, might be because of the cost concern and privacy concern. We wanted to make sure that we remove all those difficulties so that it can reach its potential. Okay, in terms of a company, we do from hardware up to cloud applications. Okay, our company is now 7 years. I need to update my LinkedIn. That years pass so fast that I myself forget. 7 years we are running the company, and our specialty is that you will see a lot of companies collecting investment in millions and billions. We are a company, we have not collected any money from anybody. We started self-funded and we are profitable and we run with customers' money. Okay. And we are mentored under Cisco Launchpad. Cisco Launchpad is one of the best startup accelerator out of India. And we are also accelerated by Qualcomm. They both are leaders in their area. We are a small company, 20 plus, and we have a 20 plus engineering team. And we have deployed over 50 plus IoT solutions in this 7 years. Very, very happy about that. That's the company. In terms of, give me a second. In terms of expertise, I divide that into two categories, which are the vertical, what we are focused on. One is industrial IoT, where Industry 4.0, what we are going to talk about, comes under that. And smart cities is basically, you can see the applications, street lighting, parking, metering, sensor and remote management. We have been focused very much on that before, but now our focus is between industrial IoT as well as smart building. Okay. In terms of what do we do? What we do is that if you look at in all this IoT, most important thing is that wireless components. Like, for example, you would have heard of wireless LAN, Bluetooth low energy, RF mesh, ultra wideband, cellular, all the technologies we have expertise as well as components we build. Okay. And then what we do is that create building blocks Building blocks are some sensing nodes, for example, environment, radar, control system, and all of them. For example, movement detection, preventive maintenance, all of them requires building blocks. We create that building blocks and keep. Then what we do is that for a particular vertical, we develop end-to-end solution. That's the way we work, and then deploy that solution to market. That's the way we work in terms of our the way we run our company. Okay. In terms of partnership, we are very happy with very, very big partners we have, even though we are very small. Basically, people say that you are shooting from somebody's shoulder. Somebody's, yeah, that's correct. Okay. We are in terms of semiconductor, you can see, other than my old company, I'm partnered with everyone else. ST, Qualcomm, NXP, Silicon Labs, and Nordic. And in terms of connectivity, I mentioned before, these are the connectivity standards we are working with. In terms of cloud, all three vendors we work with. In terms of ecosystem, I mentioned that Qualcomm, we are part of Qualcomm Advantage Network, Cisco Launchpad, NXP Partner Program, and Accenture, and Apple MFI. Okay. This is about Atoll. Anybody has any question on what we do, and then you want to know more about our company, you can ask now.
So is there any capacity limitation requirement for creating such facility by any company? How much capacity of storage can be made available through this?
There is storage is basically a separate part. One example I'll tell you. You are getting information about. Maybe I will show you. Then I think this is the best way. Can you see my screen? Can you see a device, black device?
Yeah.
Yeah, this is an anchor.
Okay.
Yeah. This is a device. What it detects is that it identifies devices, for example, any kind of assets, people, all of them with this kind of tag. Okay. And that sends that information through wireless technology to a gateway. Gateway is in our other room. That gateway sends the same information, and it does a lot of number crunching and algorithm on that. And the resulting data, it will send to the cloud. What it says is that, for example, if it is put with an important asset, it will tell that that asset is in the room, in the team room, where I am sitting now, right? That doesn't require much storage. It is in transition, it will be stored in cloud, but it is more, storage is much limited. What it requires is more detection and algorithm to identify where it is. Yeah.
So whatever information or data we would like to store for a long time, so basically it will be remaining in the Google Cloud only. That is
Amazon or Google Cloud. Okay. And then they're known as databases, and you pick it up later and then do more analysis if you want.
Okay.
Somebody else had
Thank you.
Jitu, Professor Bhaskar Gupta has joined. Professor Bhaskar Gupta is actually our course director. He is you can say ICT specialist and professor of eminence of Jadavpur University. Bhaskar, please open your video. Bhaskar, hello.
Yeah.
Hello, Bhaskar. He is not audible, but he is there in there. Okay,
okay. Am I audible now?
Surely.
Okay. Good afternoon, Jitu. I'm listening to you.
Yeah.
So let me listen to you. Okay.
Thank you. Thank you. Thank you. We have very good connection when I was in Texas Instruments. A lot of IIT Kharagpur and Jadavpur University
Good.
people. Our MD was from Jadavpur originally, Bobby Mitra. He is now in US. Okay.
I see so many people from all places there in Siemens and in other IT companies too.
Absolutely. Yeah, yeah. Even in DRDO,
Yeah.
I was in DRDO for a few years. Jadavpur, everywhere.
Yeah.
Bhaskar is a coordinator of that project, that DRDO. I mean, he is the coordinator.
There are many projects.
Jadavpur,
Many projects
right.
are there. Jadavpur, DRDO. We are now having we are starting the Center for Advanced Studies with DRDO. Actually,
Oh.
there's a center named after Sir J.C. Bosch, run by DRDO in Jadavpur University campus. Anyway, let me hear to you now.
Yeah. My wife.
Okay, very good. Please carry on.
Nice meeting you.
Yeah, my wife works for DRDO. She is a division head for unmanned aircraft integration in ADE, Bangalore.
Please carry on. Okay, thank you very much.
What is next question is that what is Industry 4.0, right? Because most of the time people like to coin nice terms and then stick with that. Industry 4.0 is like that, a kind of a hype thing people talk, but it is good to understand. If you look at a chemical engineer, you need to understand one thing, that how the transition happened in terms of 1, 2, 3, and 4. Okay, the core industry remained the same, but different level of efficiency improvement and network improvement makes it more efficient. That is the change from 1 to 2 to 3 to 4. Okay, and if you look at Industry 1.0 was basically steam powered and weaving loom. These were the most important thing, mostly in England. And Industry 2.0 was mass production assembly line. It started with Ford Motor Company in US, and then initially the factory started using electricity. Okay, that is the Industry 2.0. Industry 3.0 basically it is around 1980s. You can hear things about RS-485, that kind of connectivity. Automation started in very limited level of computers and electronics came into industry. Okay, and if in India, most of the chemical factories, everything is running still in the Industry 3.0 framework. There are some automation, but most of it they do with Excel sheet. You would have seen it if you would have visited some of the factories. You can see that they still use board and choke and board, Excel sheet and things like that. They're not moved to Industry 4.0. In Industry 4.0, what happens is that you would have heard terms like digital twins, AI, ML, Internet of Things, and complete networking, wireless networking, all put together. What happens is that even manufacturing or any chemical process becomes actually not an industrial problem alone, it becomes a digital problem. That is what is Industry 4.0. For example, I'll tell you, you guys, chemical engineers, had an amazing time in 1940s, 50s, and 60s. And if you look at, there was a dull period from, I think, 1985 to around 2000 time frame. But now, your time is coming back, amazingly coming back, because you heard of electrification in terms of dependence on fuel, basically like petroleum products, coal, All of them are trying to come down. When it comes down, the most important stuff is actually electricity storage. Still, lot of innovation opportunities are available in terms of battery. If you have time, you should look at a company called Log9 Materials from Bangalore. Log9 Materials. They have come out with an amazing battery technology, which really every chemical engineer should look at. Battery technology as one of the area where you can innovate to make a huge change. Any question on the Industry 4.0? Can you hear me?
Hello, sir.
Yeah.
Sir, my name is Biswandu Vera. I am from Jadavpur University, Chemical Engineering Department, third year. Sir,
Yeah.
my question is that we have heard that most of the batteries are made from lithium ion, and that is very sustainable and useful for our society. And except lithium ion, is there any ion which create that type of sustainability and that type of useful, except lithium ion?
Yeah, I think the problem with what happened, I'll tell you what happened, as I mentioned, there was lack of investment in chemical technology. The problem with lithium ion or lithium polymer, that kind of technology is that they all use rare earth materials. Okay. The problem with rare earth materials is that it is rare. Okay. Even if you try to expand, if you look at the kind of pace in which electrification is happening in terms of automobiles and other areas and solar storage, there will not be enough material available. And what happens is that most of the time, people who has a lot of money and power, okay, like for example, Tesla or other big automotive vendors. Can you hear me?
Yes, sir.
Yeah. All those, they will take over all the material available in the world. And that material also, you should see that there are only very rare places, basically places like Chile, South America, China. These are the places this is available. India has zero rare earth material availability. Therefore, India's dream of becoming independent in terms of an electrical future will be in great difficulty if you don't find some other way of other battery. This company, Log9 Material, you can look at it, it's a startup from Bangalore. They have developed a battery which works with aluminum. Okay, you are chemical guys, you can go and check it out what it is. I'm showing it to so that you will always look at this and see what kind of innovations are happening in India. This is based out of Bangalore. The beauty of this technology is that aluminum is available in India plenty. Okay, and what happens is that when you run this, what happens when your battery, lithium polymer battery or lithium ion battery runs out, you have to go and charge, right? In the case of Log9 battery, you just have to change the aluminum rod. Unbelievable. You should go and look at it as a chemical engineer. Okay. Any other question?
No, sir.
You understood now why? What is the problem with lithium ion, right? It is not available enough.
Yes.
Okay. Next one is basically how do we succeed? For example, you looked at the definition of the Industry 4.0. How do you succeed with Industry 4.0? most important thing about improvement is that you have to measure, isn't it? Unless you measure, you can never improve anything. For example, if you have a problem of not getting up in the morning, unless you intentionally identify that you have that problem, you cannot fix it, right? Same way, if you want to use go into Industry 4.0, improve the efficiency of a plant, you need to first measure basically what are the limitations of my process, right? That is the first part which I am going to talk about. In this particular thing, there are two important things which I'm going to talk about. This is not the only one, right? One important thing is that location intelligence. For example, you are bringing input for your factory. Okay, you wanted to know how much time your truck which comes inside your factory area, it takes in different zones. For example, if you are unloading something, how much time it is taking to unload, and which all places the truck is going. Is it going somewhere else which is need not go? That measurement will allow you to make sure that you optimize the path, right? Second one, for example, there is a workers are there in different part of your factory. There is a particular worker who is supposed to be in a machine room. If he is not there, your output will not happen enough, right? Properly. That is known as location intelligence. You want to know whether items or people are at the right time, at the right place. Okay, that intelligence you have, you can improve in terms of your efficiency. Okay. Other intelligence we need to have is sensor intelligence. Sensor intelligence, one example I'll tell you. In a process factory, an equipment stopping for a day will be crores of losses to the factory owner, right? For example, it's a process machine. Suddenly it stops and repair. For example, if you take an example of maybe the factory is in somewhere else in West Bengal. From the repair guy has to come from Kolkata. Okay, it is actually 2-3 days of loss. You think that if you can predict that problem 1 week in advance, and the repair guy comes without you telling them, okay, and comes up, repairs and goes. Therefore, you save 2 to 3 days and time as well as huge money for you. Okay, that is one thing. And another thing you have to look at is that when you are building a new factory, it is known as greenfield. I don't know whether you have heard of Ola scooters, which is just came out today or yesterday. They started selling. Okay.
Yes, sir. 600 crore rupees.
That is a
they have.
Yeah, it would have cost even 600 crores more than that. But their factory will be the largest scooter factory ever built in the world. Okay. And it will be all women factory with complete Industry 4.0 from start. That is known as greenfield. Then you don't need to worry about anything. Okay. Everything is fresh. Only thing you need to have a good will, determination, and money, isn't it? Everything else will come because the latest technology available, you can put up everything. That is greenfield. But if you are doing a brownfield factory, if you look at, for example, a chemical factory in the outskirts of Kolkata, which is 100 years old, how do you make sure that I improve efficiency of that particular factory. That is known as brownfield improvement. Both are important, right? You cannot simply shut down an old factory because some of the technologies of chemical technology has not changed. For example, a cement manufacturing, but we still need to improve efficiency. That is the two different types of measurement and path to success. And once you get all this measured result, what do you do next? You look at productivity improvement, right? You found out that there are some people who are consistently not going and working. You identified that. What do? You either tell them if they are this leaders like in Kerala and Kolkata, there are some leaders who will never work, right? You cannot do anything with them. If they are not that kind of people, you make them work, or you tell them that you learned, or we need to give opportunity to some others. And if the efficiency improvement, the problem is not because of individual, it is because of a process. You change that process so that productivity improvement happen. Okay. And other one, what you do is that business model innovation. If you look at most of the people now have direct order. If you look at this Ola scooter I was talking about, there is no shop required. You order with your address, scooter will be delivered to your address. They don't need any shop. It is directly driven from the factory and given to you. That is a business model innovation, right? You can save a lot of money and and improve overall business advantage also. Once you do all these things, then you win. That's the way we work with our customers. That is what I wanted to run you through. Now what I'll do is that I don't know whether you can ask some questions about this process in Industry 4.0. I can answer. I'll move. This is little bit of technology, and it is outside of your expertise, or maybe not interest. You will always, all of us like it because we all use it in our phones with Google Map, right? Google Map is the solid example of location intelligence. If you think of map and Google Map was not there, you think of there will not be any Ola, there will not be any Uber, isn't it? Every business has come in because there was a location intelligence on the phone, okay, mobile phone. The same intelligence what you want to bring into your factory and warehouse and places like that. That is what our company is working for. What is a location intelligence? You want to know where, who, and when, right? If you answer these three things and do analytics on top of that, you can solve a lot of problem in the world. That is what is location intelligence. When did it start? Okay, it is not new. It is an old 1916. World War I is the first time people started using location intelligence. Then if you look at GPS came in 1973, that GPS is what changed everything in Apple iPhone first and then Android, right? That started long back, 1973. I was just 4 years old then. Some of you, most of you have not developed that and born at all. Okay. And the next one was, if you look at indoor positioning of first started by MIT in 2005. Okay. Then another one is BLE was introduced by Apple in 2010. That changed a lot of things. Bluetooth Low Energy, you heard of Bluetooth Low Energy? And in 2018, ultra wideband alliance was introduced. Just to give an example, ultra wideband allows you to track something in centimeter level accuracy. Okay, you can go through this when you after this, you can go all these names, go and search all these names. You will learn quite a lot. Okay, there are two important names you have to understand when you look at location intelligence. One is ranging. Ranging means, for example, have you seen in a road, radars are kept, right? Police keeps radar to see that how are you crossing the speed limit. Is there in Kolkata that one? Or Kolkata doesn't have a speed problem at all?
No, it is there. It is there everywhere. In Kolkata
Yeah.
itself, in our Salting Newton area, there are so many.
Yeah. That is known as ranging. Okay, what it is doing is that your car is the object. The radar, what you are seeing on the side, is the sender. It is sending RF information and getting back and identifying distance and velocity. Okay. If you identify the distance, you can identify velocity. That's the way they are identifying that you are going over speed. Okay. That is known as ranging. Another one is, for example, tracking is actually like when you book a car with Ola, you look at the car coming in, right? It is coming towards your wherever you are waiting. That is known as tracking. Okay. You understood the difference? One is localized, ranging is localized. It is between that radar or whatever it is and the object. In tracking, you have been located or tracked by some central system. First, GPS will send the data, and GPS satellite information is collected by the mobile phone of the driver, and it is sent to Ola's server. Ola identifies that and then gives you that information. Okay, it is centralized. Understood? Am I going?
Yes, surely.
Yeah. And
Yes,
if you look at location, location has three kind of levels. One is presence. For example, you have a corner shop. Okay, take an example. He has purchased some maybe a TV in his shop, right? One TV in that shop. And what he is doing is that he wanted to make sure that somebody is not taking and going away with that. Okay. What he is looking for, he wants to know that that TV still exists in his shop. Okay. That is known as presence detection. You are not bothered about in the shop where it is. Isn't it? The second one is known as proximity. In this, what you do is that in a factory, you take an example of you have an equipment which can be in three places. One is in storage area. Second one is in the machine. Third one is in the repair shop. Okay. It will be amazing to know where that particular equipment is. Then you know that, for example, you are getting an order. If you need that equipment to be in good shape to manufacture, right? Then you need to know only where it is, basically in which zone it is or which proximity it is. Whether it is in the storage area or is it attached to the machine or if it is in the repair area. That is known as proximity. Okay, in different zones. Third one is position. You want to know in centimeter level in a factory or anywhere where that particular item is. One example I'll tell you. You have seen, I don't know whether you have seen in video at least, robotic arms which actually manufactures cars, right? It goes and fits a screw and things like that. If you want to make it work, you need to exactly know in centimeter level where the car chassis is there, right? You should not go and put the tightening of a screw in a wrong place, right? That is known as positioning, accurate positioning, right? These are the 3 levels of accuracy required for location intelligence. Okay. Next, I have told some examples. I'll tell you. Presence. Self-tracking means you are tracking yourself, right? For example, if you are driving your own car, you want to know where you are and drive towards one place, right? You yourself are identifying where you are. Okay, that is known as navigation. Okay, if you take a presence use case, you need to know only you are in that particular place. You don't need to know which part of that place. Here, if you look at in self-tracking, we are looking location reporting. Here, you are doing indoor navigation. For example, in big malls, maybe in Dubai and places like that, you want to go somewhere, you can get navigation maps inside the place. Same way, factory, you have a robotic vehicle. It can automatically go to pick up an input material and deliver in the correct area. That requires this kind of accuracy. Okay. In remote tracking, this is basically RTLS and things like that, which I don't know whether I can explain. This is people monitoring, asset monitoring, all of them. Okay. That is important in remote tracking. There, the asset is being tracked by, I explained that to you. For example, a car is coming to pick you up. Similar way, a truck is coming inside a warehouse. You want to know where the truck is. That is known as tracking. Okay. For example, that kind of tracking proximity is sufficient for truck. If you are looking at an exact position like collision avoidance, you need to have absolute positioning. That is an application side. Then what are some of the other application use cases in Industry 4.0? One is productivity improvement, I have told, optimum asset deployment, locating tools and equipments, and inventory management. These are some examples of application in a factory. One example, I told you this, for example, if this is actually a robotic arm, if this robotic arm knows what type of this car this is, it can do a much better job in terms of assembling rest of the parts. Okay, this is the importance of location intelligence. I will skip this. Some of the technologies, have you heard of RFID?
Yes, but
Yeah. One example is that all of our cars have a tag in front. Toll payment is automatic now. That uses RFID. Okay, when you go through toll plaza, there is an RFID reader on top that reads it and identifies that it is your car, goes to your bank, take out the money, and opens the door. That uses this technology, RFID. Okay. Wi-Fi is not very popular in India, but in US, lot of the tracking happens with Wi-Fi. Wi-Fi is not that accurate. Next one, BLE. Bluetooth is very active. We have a lot of business around using Bluetooth. The beauty is that it is very low power. Okay, you can get this tag. It's a Bluetooth tag. It has a battery life of 4 years. You stick it into one of the asset. You don't need to worry about battery change for 4 years. That is amazing, right? Okay. You look at the tracking picture, what is written, shown here. This is the way the tracking happens with Bluetooth. Ultra wideband I talked about. This is the most accurate and most advanced way of location tracking in the world now. And we are also working on this. This gives, the problem it is that it is very expensive and power is also not that great, but you get amazing accuracy. This is about, till now I talked about location intelligence. Okay, any question on this one? You will, I think the problem is that you are chemical engineers. Some of them are Latin and Greek for you. But once you start looking at these names and start going and reading, you will understand and identify some of the use cases in your own areas. Okay, you will start appreciating. And my email ID will be there on top, on the bottom of the presentation, and you can contact me if you have any doubt after this. Okay. I will go to the next important one, sensor intelligence. This is an amazing use case. We worked on a solution. This is not from the air. I have practical experience. These are, I told about motors, pumps, which goes into huge chemical factories, and they are one day stopping them will cost the company in crores. Okay. What we do here is that we have vibration sensors, which is put on this motor area, and also temperature. Okay. That information is collected, and there are AI, ML, artificial intelligence based algorithms. What it does is that over the months, for example, you go and put your sensor into this motor, it start working, and you will identify what is the normal operation in terms of vibration as well as temperature. And over a few days, you will have tuned to identify what is the normal operation. And the moment some variation happens, you immediately inform the motor pump owner company, saying that we are seeing an unexpected behavior. Please, this might be a reason, there might be a problem coming through. Please come and repair it. This is known as predictive maintenance. Basically, repairing something before the malfunction happens. This is very critical area in your business. Okay. And what all things you look at? You look at vibration, how much power it is taking, how much noise it is making, how much heat it is making. Okay. This we use in our solution, we use heat and vibration. Some other people use power. I know that Bosch has a solution in which only they look at how much power that motor is taking from the main line. If the power is taken more than usual, they know that something is happening. It is amazing, right? What it can do. It can save millions and millions of dollars by identifying early. Next one is basically, I don't know whether you know tool and die in car manufacturing and other stuff. Lot of usage is there for tool and die. If you identify how many times that particular die is getting used, you will know the productivity of a factory. Okay. And also you will know when that tool and die will get damaged. Because if a die is supposed to be used for 50,000 times, you will make sure that when it reaches 35,000 you order for the new one, so that you don't need to wait for 2-3 weeks when your 50,000 reaches. That is another use of some kind of sensing. And second one is that usage monitoring of forklift. You can have usage, movement detection of forklift, how much weight it is carrying. If somewhere it is stationary, you can inform the rental guy saying that this, you are not going to make money this month. That guy is not using it. Immediately you can take it out and give it to another factory, right? Another one I mentioned about forklift collision avoidance. It requires multiple sensors and ranging and location intelligence all together. We need to do it. Okay. Another one, you remember that I mentioned about brownfield factories. They are all old factories. There is a mechanism in which you can fit in new sensors using some kind of additional stuff into the factory system, so that you can create a automation even for the old factories. That is known as brownfield work. We have done many work for that kind of work. Okay. And I don't have too much time. We started late. I have some notes for you in terms of Industry 4.0. If you look at around 5 to 6 years back, I would have told you Industry 4.0 is just a hype. Okay, people are simply using some nice words to get some brownie point. But now I can assure you that that level is over. Hundreds and hundreds of companies have shown success and importance, identified and appreciated the importance of Industry 4.0. It is out of the hype cycle. It is real now. Okay. And what happens is that if you look at when I was started talking about my company, I told that we build standard building blocks. Okay. That is a must for any solution. But every problem will have a custom requirement. For example, a battery factory will have a different requirement compared to a car factory. Okay, you need to have that custom modification is required in solution. And one more thing is that if you want to involve Industry 4.0, you need to identify your biggest pain point. In our industry, we say that we have to solve headache, not vitamin. Vitamin people don't buy if it is absolutely not required. But if you have a severe headache, you take a medicine. Therefore, you need to identify the biggest problem in a factory or anywhere and try to solve that with technology. It should not be a me too or some improvement stuff. Okay. In terms of approach wise, you start very small. You solve a small part of the problem and get excitement from the customer and then go and do full implementation. Otherwise, nobody will give you money to implement. Okay. And even small wins will have big impact in terms of a chemical factory or anywhere. You show an amazing improvement with very small investment, they will be ready to invest more to create more and more impact. That is my notes. And then I'll come back to you. I want to know, this is my email ID. Now you can go to questions. Anything you can ask.
Any question, participants? Because actually, Mr. Jitu, he explained so nicely and so lucidly that even after each slide he asked. So I think whatever questions you had, so already your doubts have been dispelled. So like that, we have our, so thanks to Jitu. And let me introduce Mr. Rajiv Mukherjee, Professor Rajiv Mukherjee, Professor Dr. Rajiv Mukherjee. We tell Rajiv, but He's a very, very, very big man, you see. This is, you can say, the type of audacity we get when we are becoming monk. But I should not commit this type of mistake here, because this is a, you can say, scientific professionals gathering and also the students. This is the credentials of Professor Dr. Rajiv Mukherjee. He is from Texas University. We are just sharing this just a moment. Professor Bhaskar Gupta is here, I think. Professor Gupta, do you have any observation? Hello. Professor Bhaskar Gupta, any? Mr. Jitu is a leading professional, entrepreneur in IoT field. Earlier, he settled in abroad and then came to this country and started his own business in Bangalore. That is Atoll Solution. So nice to interact, all of you. The screen sharing is yet to come, I think so. We can have one or two words in between. Our coordinator, Roshananduda, is here. Roshananduda, you wish to say anything?
First of all, I should convey my gratitude to Mr. Jitu for giving such wonderful presentation, because as I am also a chemical engineer and worked in ONGC for 34 years, definitely this is a new chapter for me for Industry 4.0. We are all listening these words for the last 1.5 years or so, and we could understand that how big the application of Industry 4.0 will be in future also. But what I could understand, sir, from this, apparently, that is it merely focusing the reduction of time management, basically. Suppose for searching certain things, it usually takes time, but by the application of artificial intelligence or the instruments or sensing equipments or all those things, it is merely giving the benefit of saving time.
Yeah, it is. That is one part of it. But I focused on two areas. One is time. Time is always money, and more than that, everything has to be in a particular place. If you want to use an input component, it has to reach that whatever conveyor in time. That is also important. You need to make sure that it reaches there. It is just a different component. The basic thing is that whatever you need in your factory is the most important. Technology is only to aid. It is never a solution. Solution should come from your requirements.
Individual, basically.
Each place has different requirements.
Yeah. No, actually, saving time sometimes may create unexpected problems also, no? Because nowadays what we find that the patience of each child has gone down tremendously, because what we have seen for the last 30-40 years, people are usually having the habit of waiting for some time to get the perfection, to reduce the mistake. But now, because of reducing the such patience,
Yes.
and going for faster, mistakes also do happen. Of course, we are to 100% depending on the instruments then, instead of using ourselves for, because the designs what you will make for making any instrument, that time it has to be very particular to take care of everything. But practically when we apply, we find that a lot of manipulative situations are getting created, like cyber manipulation and all those things. So that sort of, I'm not criticizing the development of it. I am just finding that there are some inbuilt problems also being created through Industry 4.0. If we take the only the better part, it's good. But if we
Yeah, absolutely. I think
concentrate only the
security, yeah, security is the biggest problem. I think Rajiv, maybe he'll be able to talk about it. What happened in US in the recent past? A lot of intended hacking happens, but the advantages over, I think, is much more positive than whatever solvable limitations. That is the advantage.
Yeah, of course, there are very plus points, I mean, advantages. But one more thing that we are now operating with a number of apps, basically. They are simplifying the procedures to get the result quickly and correctly. But many of the cases, we find that the modality of the apps are going in a different of its own pattern. Because earlier, if we see that nut size, bolt size, they are all standardized. But now, if we find that any app is, for example, a Swiggy app, now another app is there, for example, Zomato, they are not having the same procedure to follow. They are creating their own pattern. And in that way, it's a problem for the operator basically to learn so many or to be attentive for each and every app which goes in its own way. Am I correct, sir? I mean, can it be standardized? I mean, many of the things.
Yeah. Standardization happens at the end of the curve. Okay, innovation happens and it stabilizes, and standardization happen at the end of the. Whatever you are seeing, if you look at all the application, everything, they are just coming up. Therefore, it will be always proprietary and things like that. Once that is stabilized, then standardization happens.
I think standardization is very much important, sir, because if you go to the
industry, it is very important.
Yeah, because if you go to sir ATM also, for example, each ATM has got a different sequences to be followed. So why it should be?
I think Ashwinendra,
yes, sir.
I think let us stick to the schedule. Definitely,
Oh,
actually, already
I don't want to get
joined and we have, streamed his.
Yeah. Right,
of course, he needs no introduction. One is basically because of his credentials, number one. Number two is in our inauguration day, he spoke for 5-10 minutes, but he will elaborate the whole thing, Professor Mukherjee, Rajiv Mukherjee. He is Assistant Professor, Department of Chemical Engineering, University of Texas, Permian Basin, Odessa, Texas. His research interest is multivariate statistics, machine learning, and stochastic optimization. He has worked with so many universities like Texas A&M University, Vishwamitra Research Institute, U.S. Environmental Protection Agency, Tulane University Center of Computational Science, Louisiana State University, and then before that, his starting career, that is CSIR, that is National Metallurgical Laboratory, Jamshedpur. Incidentally, let me mention that I am also the empaneled expert of CSIR NERI, National Environmental Engineering Research Institute. So he has got the achievements, 35 journal publications, book chapters, and several conference presentations. He authored several books, Rising Star Faculty Grant, University of Texas System, Oak Ridge Institute of Science Education. So these are his achievements, and he is editor of this journal that is measuring progress towards sustainability. Oh, it is here, one book he has published. So like that, he is editor of so many such things. So that Professor Mukherjee himself will explain. So over to Professor Mukherjee, please.
Thank you, Swamiji. And thank you, Mr. Jitu, for the wonderful presentation. So I'm going to somehow start from where he has ended. So I will take some of the use of sensors that we chemical engineers can do in our process as well as outside the process. And from Dr. Mr. Jitu's talk, what I understand that, and he also mentioned that most of the students here are chemical engineers. So that will kind of help me to convey my message. Today, I intend to talk on two different things. Both needs the use of Internet of Things and Industry 4.0. So, can I share my screen and?
Surely.
Yes. Okay. So, can you see my screen?
It will come, I think. It will come within 1 minute or so.
Okay. So, so what I okay. So I don't know why it is. If I go to the particular. Can you see my presentation? Let me know.
No, sir.
No,
Not
it
yet?
has
Okay.
not come till now.
If I go by. Give me just 1 second.
I know. এমন ওর প্রেজেন্টেশন কেন এ হচ্ছে না ও তো প্রেজেন্ট করা আছে তো হ্যালো
I think
রাজীব
it's. Let me try in a different way. Share my
জানি না ও প্রেজেন্ট করতে পারছে না দেখছি ও বলছে লেট মি ট্রাই ইন এ ডিফারেন্ট ওয়ে মানে তোমার মাল্টিপল করা আছে তো
আমি
না ও
entire
করেনি
screen
ও তো
share
এখন
করতে চাইছি।
ও তো এখন আসেনি না তোমার তো তুমি কি লিভ করে গেছো নাকি আরো
না আমি দেখতে পাচ্ছি কিন্তু স্ক্রিনটাতে শেয়ার হচ্ছে না মানে আমি দেখতে পাচ্ছি না আমি বিবেকানন্দ ইনস্টিটিউটটাই দেখতে পাচ্ছি দ্যাটস দ্য থিং let me go by the window let me share the Microsoft
please do it
no
again please do it again
okay the entire screen no a share screen it's showing some kind of error okay if I go to the next one Microsoft PowerPoint no what It is showing that the Microsoft PowerPoint, it can share, but when I'm hitting the share, it's showing that some kind of error is there. I don't know why. Do I have the permission to share?
Yes, actually we made it multiple sharing. I mean, that mode we set it. And just now, Mr. Jitu was sharing, and our, I mean, transmission coordinator, she shared your slide. So again, we checked that whether this is there. Can you share using PDF? Do you have any? Can you make it a PDF version?
I can make a PDF and send it right now. So.
Or can you send it this material itself?
Yeah, I can send the material. Yeah.
Just now we send it. Let's see, share it.
So.
Hello.
Yeah, I will send you the material. Okay.
Can you rejoin again? Can you rejoin once again? Then generally this type of problem solves.
Okay, I will do that.
You can try sharing the whole desktop. Look at
I'm trying that. That's the first thing I tried.
Oh, that was this work. Okay.
Is it because I'm using the browser to join? I can have the problem, or is it because I'm not using any app to join? It is not telling me what is the. Okay, Zoom wants to share the components of your screen. Yes, I'm saying to share.
Don't you have the I mean Zoom
Oh,
app?
please grant browser access to screen recording. Tashi Sengupto to everyone. Please grant browser access to screen recording. That's what I'm getting, the error. Browser access to screen recording. What does that mean?
In browser version, you cannot share the screen, I think, sir.
Oh, if I'm in the browser mode, I cannot share the screen.
Don't you have that Zoom app?
No,
I mean, in your
because
laptop?
this laptop is from my office and I cannot download anything that I want.
Oh, I see. Then what do you do? You send it, send the presentation to me. Have you sent it?
Okay, no,
Send the
I can.
presentation to Vivekananda Institute. Then she can operate that.
Okay, I'll do that.
Okay.
So, yeah, that may be the reason. Okay. Yeah, I just sent it. So if you can, yeah, I just sent it right now. If you can, I mean, go slide by slide, then I can explain on that. Maybe because I'm in the browser mode, I'm not able to do that. Let me know if you have got it. Hello? Hello? Can you hear me?
Yeah, we can hear.
Okay. So did you get the email? I just replied to the.
Yes, I got it. I got it. But let me share it. Okay. Thank you.
Okay.
আচ্ছা শেয়ারে গেলাম হ্যাঁ হ্যাঁ আসছে কি না শুধু ওইটাই আসছে ওটা তো আসছে না 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 আমি তো এখানে দেখতে পাচ্ছি না জিনিসটা আমি তো খোলা আছে কিন্তু আমি দেখতে পাচ্ছি না 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 এটা তো ডাউনলোডই ছিল আমার ডাউনলোডে দিলাম সেন্সরে দিলাম
আগে ওটা পুরো ডাউনলোড করে নিন কম্পিউটারে।
হ্যাঁ করছি
হ্যাঁ, তারপরে পাঠাচ্ছি।
হ্যাঁ আচ্ছা ডেস্কটপে গেলাম আচ্ছা এবারে এখান থেকে খুলবো আচ্ছা না এবারে আবার আমি এটা খুললাম জুমটা খুললাম জুমটা খুলে হ্যাঁ এবারে শেয়ারে গেলাম না তাও কেন আসছে না বলো তো না দাঁড়া 1 মিনিট ও এটা তো এখানে খোলা নেই দাঁড়া 1 মিনিট না ওই যে জিনিসটা কোথায় গেল মাল্টি কোথায় গেল বুঝতে পারছি না
Yes, sir, it has come now.
Okay. That's it. Okay, thank you. Sorry, I think because I'm doing it from the browser, it's not working. But I will talk about what I want to talk in different slides, and I will say next. And if Swamiji, if you can move script to the next one. Okay. Thank you all for coming to this talk. And as I told, I will continue what Mr. Jitu was discussing about. So we take extensive use of the sensors and what we do with that. So the first example that I have, which I'm going to talk here, is on optimal placement of sensors for monitoring air pollution for health impact assessment. Actually, what happened is I'm not going to be specifically talking about industries, but we take the advantage of some of the algorithms and methods that is used in different industries, especially chemical process industries, which I am familiar with, and how it is used in other applications as well. And this is an example, like monitoring the health impact. You all have heard about drones, and drone is one of the most popular way of monitoring pollutants nowadays, especially in big industries, ExxonMobil and all, like big industries. What they are doing is they are putting their drones in the battery limit. Battery limit is like, which is the boundary of their production facilities. And the drone is actually continuously monitoring the pollutants that is actually going generating inside the production facilities and going outside. So this work is actually extending it, taking some of the technology that is used there. And I will talk little bit about the theory behind it, and that may intrigue you a bit more. I don't want to go into details about the mathematics of it. But one thing is that because this is a workshop session, it's not a lecture presentation, you can always stop me and ask me questions. There will be enough things on which you may have doubts and questions, and we can discuss about that. That's not a problem. I will give a brief introduction of the current problem that I have worked with, and this is a sponsored project from Energy Research Institute, an institute in California. And so what they wanted to do on that, then I will tell what is the goal of the work, how we define the problem, and then problem formulation is basically the mathematical part of it. It's called so therefore there are different ways to represent optimization, and I will tell you why we need to optimize this monitoring techniques, whatever we are monitoring with the sensors. Then what are the solutions? I mean, there are several ways to come to these solutions, but I will talk about only one, and this is an algorithm which is an in-house developed algorithm developed by one of my mentors, Dr. Urmila Divekar. And how we implemented that, and then how we have measured the impact of putting the using that algorithm for the data that is generated by the sensors. And finally, there will be a case study. Next. Next. Can you go to the next, please? Okay. Okay. First, the problem. The problem is on spatio-temporal sensor placement. As the name suggests, we want to optimally locate sensors in space. That means spatial location. For example, I can give, I assume that most of you are from Calcutta, and I will give you the example of Calcutta, because I'm from that city and I lived there for 18 years. So I will give you some example from that, though this case study has been done on the city of Atlanta. Okay, so the problem here is, every city, we know that in an urban life, we get a lot of pollutants, and the automobiles is the main pollutants in that city. So we see here two figures. The figure on the left is actually showing the population density during working hours in the city of Atlanta. And it's a heat map, and so those regions with a high intensity, they are more populated. Naturally, these are the downtown area where during the office hours many people and cars they gather. The figure on the right, and I'm telling left and right based on this slide. The figure on the right is the main artery, the main roads in the city of Atlanta. Okay, now what we have in that city is we have sensors to measure the number of cars in those streets per hour. So there are sensors that can monitor the number of cars, and but it cannot monitor the. But we are trying to implement some sensors that can monitor the amount of pollutants. Okay, we can make a rough estimate of how much pollutants each car will create. Okay, and then we can, based on the number of cars, we can say that this much pollutants it is creating. But what we see that that may not be exactly the same amount that we want to measure. More importantly, we those sensors that is measuring the pollutants, and these pollutants by these pollutants we mean the NOx, SOx, then particulate matters, carbon particulate matters, then VOCs, which is volatile organic compounds, everything that comes out from the car exhaust. No matter when we put a catalytic converter or whatever it is, there are some amount of pollutants that we can always get, and we can make an estimate of that, make a rough estimate of that. So this can tell, so the sensors that we already have there, it's basically counting the number of cars. And there are websites, these are open source documents. You can go and you can see that at different time of the day, how the number of cars actually in those arteries changing. Naturally, during the office hours and there are peak hours when it will increase, and then it will decrease again, and then again in the evening it will increase. So we are finding a dynamic time dependent variation according to that. There are other things in this uncertainty things in this area is called the meteorology, because these pollutants, they are not static, we know, because of the wind and all, they move out. So there are two goals in this project. One is to see that if that is the source of the pollutant, and there are, we know that there is a very important subject in environmental science and engineering, and it's called the fate and transport of pollutants. So basically it is that if some pollutants are generated at a particular location, and because of the meteorology, the wind speed and other things, and if it goes to the water, if there is a watershed, how it moves, it will transport it, and then it will end up at some other location. So when I was doing a PhD, we had a faculty, and his subject was environmental chemodynamics. Basically what it says that the pollutants, all the chemicals that we are generating, where it actually ends up, and then the fate and transport, which is like how it actually transforms and what it actually forms, because these are chemical things in nature. We don't, some compounds are very stable, and that is more problematic, like CFC and carbon dioxide and also methane. So they remain for a long time, but some other, they degrades very fast, but they convert into some more harmful and toxic things. So those are the things that needs to be monitored. But in this project, basically we are it's an optimization project, and there are two constants, like where to locate the sensors to find the maximum amount of to identify the maximum amount of pollutant. Because I will talk more about optimization, but as of now, you know that this project is to locate the sensors optimally, so that it can identify the maximum amount of pollutants that can impact human life. Next, please. Okay, so as I said, the goal is to health impact, timely detection of the contamination. As it is mentioned in the previous talk, that time is a very, very essential factor. For example, in the city of Calcutta, suppose we want to put a sensor in, say, Hajra, which was like where I actually grew up. Because it's a very busy street and so many cars are going there. If I want to put a sensor, we want to see, read the data in real time, and then also process and know how many people it can impact. So it's not only the population of the amount of pollutant is important, also how many people it is impacting, because ultimately our goal is to see the impact of human life. So, and then how we can position optimally the sensor, why we need to position optimally the sensor. If I have, say, 10 sensors and I have to work on the city of Calcutta, so there are hundreds of places where there are so many cars and so many pollutions are creating, and there are hundreds of pockets where the population is very high that may get impacted by that pollution. But I am left with only 10 sensors because it is expensive. Also, if I put hundreds of sensors, it is difficult to monitor. Also, I cannot monitor all those things at the same time. So I have to optimally locate, means I have to see that how I can maximal mitigation. Mitigation means, see, we cannot get rid of the impact of pollutants completely. So what we say that we can mitigate, that means we can reduce the impact. How we can do it maximum? So that's why we need to locate the sensors in the most optimum position. And there are many multiple challenges in this problem. One of such challenge is the uncertainty. What are the uncertainties? First is the source, the number of cars. There is no it's not a one single number that I can say that this many number cars are there in in Hajra mode at a particular time, and then every day it will be the same. Also during the time of the day, it will keep changing. So the source is uncertain, and so that's how this problem actually became more challenging for us than compared to an industry, because in industry pollutants, like, we know the exact location of the source. We know the almost very close to how much amount of pollutant it generates, because in a continuous process, uh, the the flow rates and everything remains same in the industry. So the amount of pollutants, product, byproducts, and pollutants that it creates are very much predictable. But here, these are all very uncertain. Then the uncertainty in the meteorology, for example, wind speed, we don't know, like a different time of the day, different time of the year, the wind speed changes. Okay, the temperature, it changes throughout the day and temperature. So all these things affect. Why wind speed is important? Because it will transport those pollutants. Why temperature is important? Because it will define the fate of the pollutant. The pollutant may degrade, okay, because of the sunlight, and it may form some for maybe then it may actually totally nullify, or it may create more harmful effects. We don't know. So these are all uncertain things that is there. So when we model this, we want to optimally locate the sensor. We have to consider all these things into consideration before we choose the mathematics to solve it. Next. Okay. So the next is problem formulation. Now that we know that what is the problem, we need to optimally locate the sensors, and there are cars, it will create pollutants. So we have to protect the maximum number of people. So we have to dynamically move the drones to a location where it can maximize where it can detect the maximum amount of pollutants, and then it can create a warning system or whatever it is that the pollutant has crossed certain limits. So take certain protection, but getting the information is the first thing. Okay, so the maths that we use for this problem, and this is this mathematics is used, or this statistical method is used not only for this pollutant detection, but it can be used for many other usages that I have used also. In fact, in chemical engineering, we use it for control system. So this is called Fisher information. Okay, so what this feature information, and if you are a little bit familiar with optimization, and I know, like, in many institutes they call it operations research, where they try to teach optimization from the supply chain point of view. But this optimization process systems engineering, where you are optimizing your chemical process plant, it is a very important topic. And we try to, if not in the undergrad, in the grad school, if you go, they take special care to teach optimization to the students in the process system engineering class. Also, ISI Calcutta, they have an operations research class, where mainly that is mainly designed, that course is for people who want to learn about operations supply chain optimization. So this optimization can be done in various ways. It can be a deterministic way, or it can be a stochastic way. The difference is that in a deterministic, you find you know the data at every point, so you can create a gradient, a slope, and try to minimize some objective or maximum some objective. What I'm trying to say is that that objective can be in anything. For example, if you want to optimize a process plan, chemical process that you are doing, what you will try to maximize, you will try to maximize the profit. So you take the cost of the input, the material cost and the fixed cost and everything, and you take the cost, the profit that you are making from selling the products and byproducts and so on. So and then you try to find all the parameters, all the different things that actually contribute into that, and try to maximize the profit and see how you can which parameter is like the value of each of those parameters that is contributing into it, how they maximize, how they contribute in maximizing the profit. Similar to that, here we are trying to maximize a factor, a statistical statistical calculation, which is called the Fisher information. What is Fisher information? So what happened is that whenever some, for example, I gave the example of process plan. Here I'll take directly this example here. So what we are trying to do, we are trying to find the maximum impact of the pollutants on human beings. So there are multiple parameters. One is the concentration of the pollutant, another is the number of population density, and so on. So this Fisher information also is actually a method of finding the impact of different parameters. So one parameter here is the concentration of the pollutant. So what is the impact of the pollutants in the net effect? What is the impact of one parameter, say the concentration of pollutant, in the net effect, which is the impact on human life? So that's why we take Fisher information. So the reason we do this, because there are multiple parameters that can impact one factor. So we want to know the sensitivity of each and every such parameters into the net impact. So Fisher information helps in that, and it is used in like to see the regime change, if some drastically environmental changes occurred or not in some location. So see all the parameters that can contribute to that, and which one has more impact, and so on. So similarly, we have used Fisher information here, and how we get the data. So what the Fisher information requires, we need the pollution data, we need the data from the number of populations, and so on. So how do we get the pollution data? So the US Environmental Protection Agency, they have a software called AERMOD. So AERMOD. So basically it is the transportation of chemicals it takes. So what it does is that it takes, if you specify a geographic location into that one, and if you specify the source and the amount and specify the distance, then it can tell that at different distance, at different points, if you specify the locations where you want to know if this is the source at location x1 y1, then at location x2 y2, what will be the concentration of that pollutant. And this is a open source software. Anyone in the world can download it, can use it. You just need a couple of days to learn it, but it's very excellent software. So we have used that software. So we took it, we told that, okay, the sources are those prime locations where the number of automobiles are very high, and then we calculated that number of automobiles there. We took the data, the number of automobiles there, and then how much pollutants each can create, and that's how we founded the source and the amount of pollutant. Then we used the software AERMOD we created a matrix of the city of Atlanta, and at each and every node we found the amount of pollutants using this software. And these data, the amount of pollutants and the number of population, we use to calculate the Fisher information. So the next slide, please. So that actually will tell a little bit more about Fisher information, is the mathematical thing. I already explained it. So basically, as you can see here, there is a differential form which actually says that given a random variable. So what is the random variable in our case? Say the pollution. So it's changing in the during the day. There are multiple factors that is changing it. So there's a random variable, and we know that whenever there is some random variable, there is a probability distribution of it. Okay, so some of this, if something is randomly variable, varying, then some outcome will have some probability and some outcome will have some other probability. For example, if you are tossing a coin, okay, so you can get either head or you tail, or you get tail. So head has a probability of 0.5, tail has a probability of 0.5. So it is very simple, but there are some other factors where the probability is not 50-50. The probability, like some outcome may have like head, may have some other probabilities, whereas some outcome may have some other probabilities. So especially if there are possibility of innumerable number of outcomes. Okay, so here one such thing. So we want to see that how the probability density function changes by one of the parameters. Okay, here the parameter is theta, and theta has multiple components. As I mentioned, there can be multiple things that can contribute to the uncertainty, and then we take one such thing. For example, our goal here is the maximum pollutant. Okay, so we want to know the maximum pollutant at a particular time. So that is our one of the dimension of theta, and how the density, like the distribution of the pollution, actually changes with that. So that the d of this function, d theta of the function, is actually the rate of change of the probability function when we change the maximum pollutant. Square of that, and because that can the change can be positive or negative, and we take square of that, and then we divide it by the probability function itself, and then we integrate over all the possible distribution that is possible. Okay, because there are multiple uncertain parameters there. So that's how we calculate the Fisher information. Next, please. Okay, so how we solve is, now that we know that we have the source, we know the distribution throughout the city, and we can find the Fisher information. Because there are multiple uncertainties, we can find the Fisher information and each and every node. Now we know the Fisher information. Now the question is, where should I place my sensor? The optimization part comes here. We have to maximize the information, because it is a stochastic situation. Stochastic situation means uncertain, and then we do not. So there are, as I said, there are two ways to find. One is gradient based, and another is stochastic. Stochastic is basically you randomly select some points and say that, okay, this is my solution. Okay, and then you take randomly create some other points and say that now this is my solution, and then you compare between these two. If the next one is, suppose you are maximizing, if the next set of points is more than the first set of points, then you choose the second set. So there are different ways to do the stochastic solution. Okay, and you are familiar with the genetic algorithm, ant colony optimization. I use our ant colony a lot, because it's basically somebody will feel comfortable with that. But most of those they are called evolutionary algorithms. They actually follow the same trend. So this algorithm that we have used here, it is called BONUS, BONUS. It stands for Better Optimization for Nonlinear Uncertain System. Having said that, what it does is that it actually uses a stochastic method, but ultimately when it is calculating the when it narrows down to the point, it actually uses a gradient method. So it's basically, that's why this method is very efficient. It is developed by Dr. Divekar and his team sometime back in 2004, and has been extensively used. I have used it because she is one of my mentor, and we have used it extensively, very successfully. And we show that how stochastic optimization is actually improve the solution using this bonus. Okay, next please. So this slide we can skip, and because of the time constraint, because this actually tells you the details of this bonus. So just 1 second, like if you go back, I mean, something I must mention there. So basically what it does, it uses a reweighting scheme. What reweighting? It's a statistical way of finding. So reweighting, basically you say that when you find, as I said, that you, in a simple sense, you found us, you randomly select some solution and you say that this is the solution, then you randomly select some other and compare it with the two. What this does is that this method, so when you are randomly sampling again and again, okay, it's a computationally, it's a huge amount of task to avoid that thing. Okay, what we do is that we actually sample, we take the initial data and that is good enough. We don't need to resample it again and again, but use a reweighting scheme. So basically we sample the region, the pollution at different region, find the probability distribution of it. Then we, in the next go, when we take some location, okay, and see the concentration in that location, and then we make a weightage ratio and try to find the concentration at some unknown location. So this reweighting scheme actually avoids computational extensively. I mean, we know that in stochastic optimization, one of the drawbacks is that it takes enormous amount of computation that can be avoided. Okay, next, please. Okay. So this is the flow diagram of the problem, and I'll go one by one. So this is basically, can you please go a little bit up so that I can see the entire diagram? Can we? I'm not able to see the entire diagram. Can we go a little bit up, please? Okay. So okay. So what this diagram does is that it gives the like any algorithm, any work on algorithm, we have to give the algorithmic flow diagram, because as you can see that this work is not like one single thing you do and you get the solution. You have to undergo several steps. So this is common in engineering, like we undergo several steps, okay, to go to a solution. So this is the flow diagram which says that divide the region into interest into grid. Okay, then Hammersley sequence, then you sample those region and you use efficient sampling techniques. Then you use air mod software to find the pollution in those region. Then you find the impact by multiplying it with the number of population. Then you calculate the fisher information in those regions, and finally we apply bonus algorithm to find where the optimally your sensor should be. Okay, okay, next slide please. Okay, so as I mentioned, our case study is done on the city of Atlanta, and we have taken 10 different sources of pollutants are identified. So those 10 locations are shown by these green triangles here, and you can see that it should be evenly distributed. The pollutants are monitored for 10 hours in a day, starting from 8 a.m. in the morning till 5 p.m. Along with the diurnal variation, there are also variation in different days of the year. So how that will vary, the pollution, wind speed, temperature. So because there will be summer, there will be one type of pollution, winter there will be one type of pollution. So and uncertainty. So those are the uncertainties that has to be taken into consideration. Will vary with the mean and the standard deviation. So basically, there is a wind speed throughout the year. So there is a mean wind speed, and there is a standard deviation within which it varies. Okay, so we sampled it, and then we made an assumption that the mean and the standard deviation is 3 times of the spread. The distribution is 3 times, which will take like 66, 95, 99%. So basically what we call in common term like 3 sigma kind of standard deviation. And we assume that it varies from plus minus 5% from the mean. And then that is the distribution of the pollution, and then we sampled it. So simulation is performed in 2 different ways. We did both. So when we do this solution, we do both deterministic as well as stochastic way of calculation, and show that the importance of taking the stochastic solution, doing the stochastic solution. Next, please. Okay. So this is the results that I have to show you. And it is, if you remember the city of Atlanta, and we have created the grids, and like, so you place the sensor, you define like what is the maximum number sensors that you want to use. Now you know the pollution distribution, you know that if you use 2 sensors, what the sensor should be, and if you use 4 sensors, where that sensor should be, and also a heat map to show the distribution of the pollutant. It is not only the distribution of the pollutant, but also the impact of it. So it took the number of the population also into consideration. So that's why you can see that the downtown area, they are more red than the other areas. The other areas are neighborhood where many people lives. So basically what I have to do, you have to go and in hand calculate the number of people who are present in each and every councils, and then use that numbers and take the populations, multiply them, and find another matrix and use that matrix for the calculation. And this is showing the diurnal variation. So this is morning 8. The first figure in the top left is morning 8 hours, which is the busy time. And then as days goes, you can see that, and I scaled them all the same, try to scale them. But you can see that the total pollution drastically decreases as we increase, or the total impact decreases as we move towards the day, latter part of the day, from 10, then 12 during afternoon, it reduces drastically. Then again it increases in the evening. Okay, evening 4, we can show that the last figure is the again 4, and the pollution increases because again the traffic increased. And also there are 2 sensors. We assume that there are 2 sensors, maximum 2 sensors, because the 2 drones that can monitor. So the drone can locate, that can move to a region where there are possibilities of maximum pollutants during the day based on the past data. And then if it crosses some alarming limit, because there are a huge number of population located there, it can generate some alarms. So you can see that morning 8, where should be the location of the drones. Then at 10 a.m., where should it be located? 12, 2, and 4. So different time of the day, how the drone should move in order to measure the pollutants in this region to see whether it exceeds the permissible limits or no. Okay, next slide, please. Okay, so how we measure the health impact, that's another factor I have shown we can give. So basically, every pollutant, there is a toxicity limit for that. So we take the average concentration of a particular pollutant, for example, say NOx, okay, and then whether it the pollution is through intake, because we can inhale the pollutants, it can affect our it can be consumed through our skin, which is less, but then can affect our skin and so on. So, and then there are other factors like the contact rate, what is the possibility of someone coming in contact with that. So these are all those intricate things, but not a very important challenging technical thing. So I want we can skip this one. Okay, next please. Okay, so the first one, the first figure that I have shown before, this is basically showing that the concentration of the pollutants. This figure actually shows the impact, because here I have used the actual impact, like the threshold limit which can cross, but that's why you can see that here the impact is localized at some other location which is different from where the actual pollution is. The reason is the contact frequency, the population there, they may not be significant. For example, suppose if you are monitoring the pollutions in Hajra, okay, and there is a huge population there. Suppose some other industry located near Bojboj, and there is a thermal plant there, and there is a huge pollution right next to it, but maybe the population is not high. So why to place the sensor in Bojboj? It's better to place it near Hajra, because there are so many people live there, even though the source and the is not that high, but the impact may be high. And that's why the results are given in two different format. One is to show where the pollution is located at different time, and next is where the impact is maximum, and then the drone can move accordingly. Okay. Next, please. Okay. The next analysis is that suppose if we have 3 sensors or 4 sensors, 5 sensors, how they are located, they should be located. Now I say that every optimization is done with some constant, like the maximum. In our case, important factor is the maximum number of sensors. The other factor is if we use 2 sensors, we want that the distance between those 2 sensors should be at least 10 miles. Okay. If we use 3 sensors, the distance should be will reduce. We made it 4 kilometers. Okay, so we change the number of sensors and reduce the distance between them, because the more number of sensors, the more they will be. We can gather more information and reduce the number, the distance between them, and try to see that as the number of sensors increases, where actually the sensors try to optimally locate themselves. Okay, next, please. Okay, so this is basically what we found, and this work has been submitted to the our the APRI, which is a research institute. Basically, what they do, they fund this kind of project, see the results, and they send the recommendations to the government agencies who are the planning and implementation guide, and that's how our success is counted. If it is implemented, that is our success. The other success is the application of the theory or technology that we develop. So basically, what we see that we can do a real-time spatiotemporal sensor placement problem solve using this bonus algorithm, because the algorithm should, like, the amount of computation, like there is a journal paper on this that you can look at if you want to know further about it, and it came into the journal Clean Technologies and Environmental Policies. So there you can see all of the factors, what is the computational time it took to measure how we claim that it can be done in real time. So basically, those two drones can actually locate themselves in real time, and some real data it can keep sending, and then that data can be analyzed or optimized in real time based on the number of cars, the pollutions. It can analyze and locate that and instruct the drones to move to the respective position. The other important things that we found from this is that the results from the intake formulations are significantly different from the method A, which is only the concentration of the pollutant. So this is another thing that can be that should be taken care of. Like it's not only the pollution that matters, because something that we cannot avoid, but what we have to avoid is the impact on general population. So it is also important to see that the impact on population, and there are different measures to do that, and that can be implemented. So bonus reweighting scheme is one thing that is successfully implemented for this problem. And yeah, I'd like to acknowledge this EPRI for this Electric Power Research Institute for the funding. And then there is another slide which is next to that, which actually I avoided in general, which is basically the detailed step of the solution that we have done for optimization. So basically, it is the flow diagram that I have shown. It is details of those steps, a little bit details like what is used for the paper. So this actually will give you an idea of what this drone technology, sensor technology, some technology that is used for industrial Internet of Things can also extend beyond that. So what we learn from here is that it is important, like this optimization, the theory that you learn from your school, like the undergrad theory that you learn, and also in your grad school, if you want to do further and know about this, so they are so important, and they can solve real life problem. Okay, and if you want to take those challenges and want to work on a real life problem, then basically you have to understand these theories from your school, grad school, undergrad school, grad school, and then like you have to find there are a lot of challenges there, optimization challenges everywhere in the world, and you have immense opportunity to use those theories. So because of time, I like to stop here. I thought of talking about another problem, which is real process engineering problem. This is an application of Internet of Things in environmental pollution monitoring, but there are other like process related applications are there. But I would like to stop here, and because I have another meeting at 9. So thank you for your attention, and thanks to the Vivekananda Institute and Swamiji for giving me the opportunity to present my
Thank
work.
you, sir, very much.
Thank you very much, Dr. Mukherjee. This is really, it is not only the wonderful presentation, it has a lot of depth. Actually, I also work with a little bit of statistical modeling and such type of things. Those are the, you can say, the structured models, but these structured models, how it can be used in form of the higher dimension using IoT. So that you explained very nicely. Today there is a shortage of time, so let me close the session. Participants, do you have any just one question? Anyone?
Yes, please. Any questions?
One or two questions, participants. I think they don't have the questions today. If you wish to share the presentation afterwards, not today.
Yes.
I think on Monday we have some little time for that. One speaker told that his presentation is not up to 1 hour. So if it is possible, if you wish, you can share. Otherwise, we can
Yes,
share.
yes. Because
Yes.
this is already like this has been presented in 2019 AICH, American Institute of Chemical Engineers.
I see.
Yeah, in the IIoT session.
Yes.
And then we had a paper published in 2020, I guess. Yes, 2020.
I see.
So this is like you can share with anyone, and also you can share my email address if they have questions.
Oh,
they
surely.
can
Surely. Thank you very much.
Thank
If there is no question from the participants, we can close the session. What do you suggest, the participants? Oshanandra, you have anything to say? Professor Gupta, you wish to say anything? Is he there, Professor Gupta?
Yes, I am here.
You are here. Then how can I wind up the session?
It was a nice and illuminating lecture. I was listening, but right now I don't think I have anything more to say, excepting thanks to the speaker for a nice and illuminating lecture.
Okay.
Thank you, Doctor.
Okay, bye. So let us close the session. Okay, thank you very much. Please close the session. Please close the session. Please close the session.